So here we're going to have a look at another mechanics question. This is another kinematics mechanics question from HSC/preparatory physics. So two cargo ships pass each other. They're going in opposite directions. Ship A is moving at 5 kilometers an hour, ship B at 3 kilometers an hour. 5 minutes after they pass, ship A blasts its horn. We're asked how far apart are the ships when the horn blasts, and we're asked how long does it take for ship B to hear the horn. So there's one piece of information we actually need here. We need to know the speed of sound. So we're actually going to add the speed of sound, or an approximation of the speed of sound, which is going to be 340 meters per second. So this is how fast sound travels under unimpeded conditions. So this is how fast the horn sound will travel. So first, we need to work out how far apart the ships are when the horn blasts. Well, they both start at the same point. One goes over this way, one goes the opposite way. So one of the ships is now here, there's a ship, the other ship is over here. So one of them was traveling at 5 kilometers an hour and one at 3 kilometers an hour, and they travel for 5 minutes. So to find this distance, d1, this will be, we'll convert these to meters per second, because it's going to be slightly easier for us to work in meters per second. So 5 kilometers per hour in meters per second, this is going to be 5 on 1 multiplied by, in the numerator, 1000, in the denominator, 60 squared. This gives us 25 on 18. And then 25 on 18 in decimal form. We want to round this a little bit. So for this, we get 1.388 repeater. So this is about 1.39 meters per second. And then the other ship that's going 3 kilometers per hour, we need to convert this. So this is 3 times 3 on 1 times 1000 over 60 squared. This is 5/6. So this is 0.83. So 0.83 repeaters meters per second. So we'll say 0.83 meters per second. And we'll just say that these are approximations. They're good enough because this is physics. We don't need to be perfectly accurate. We just need approximate numbers because we're never going to get atomic level of precision anyway. So these numbers will do exactly what we need. So distance 1, the distance cargo ship A travels from the point where they both passed will be 1.39 meters per second multiplied by 5 minutes. So that's multiplied by 5 multiplied by 60. And then distance 2, the distance ship B travels to get from the point where they both pass to where it is, will be 0.83 multiplied by 5 multiplied by 60. So we need to calculate both of these. These will give us the distances from the point where they both passed, both in meters. And then the sum of these is the distance between the ships. So 1.39 times 5 times 60 is 417. So this is 417 meters. And then 0.83 times 5 times 60 is 249 meters. And these are just approximations. It could be up or down by 1, 2, 3 units either way, but it doesn't matter because we're just finding approximate calculations here anyway. Right? Physics is always done with error in mind. You're almost always going to have some error, especially for introductory physics. So these are good enough numbers for us. So how far apart are the ships when the horn blasts? Well, they are the sum. The distance between the ships is going to be 417 plus 249. That's going to be 600 666 meters. 666 meters. And that's their distance apart. So that's part A. Now for part B, how long does it take for ship B to hear the horn? This is a slightly more complicated question because when ship A blasts its horn, the sound leaves the point where ship A is and heads in every direction, including directly towards ship B. Ship B, however, continues to move. So it's not just going to, a lot of students will say, oh, well, it's the time taken to travel 666 meters. No, because ship B continues to move away. So it's actually slightly longer than that. So we have to factor this in. So we start with the ships being 666 meters away from one another. At this point, the sound flares outwards this way, traveling it. So this is ship A and this is ship B. But ship B continues to travel in this direction. So we want to do this as a simultaneous equation. We want to say the sound has position equal to 341 times time. Sorry, 340 times time. We'll use 340 in this case, not 341. Whereas the ship B, has position equal to 666 meters, how far it is from ship A, plus its speed. And we were told its speed is 3 kilometers an hour, which is 0.83 meters a second. So that is 0.83 times t. Now we have these two equations which govern the position of the sound wave and the position of ship B. We need to solve these to find out the point and the time at which they intersect. That is the point and time at which ship B hears the horn from ship A. So we'll just use our standard simultaneous equation solution form. We're going to let 340t is equal to 666 plus 0.83t. So 340t is 666 plus 0.83t minus 0.83t from both sides. This gives us 339.17t is equal to 666. Divide both sides by 339.17. And this will give us that the time taken for the sound to get from ship A to ship B is 666 divided by 339.17. This is 1.9636 seconds. So how long does it take for ship B to hear the horn, assuming sound travels at 340 meters a second? It takes about 1.96 seconds, if we round this to 2 decimal places. And this is the rounding that I want. I wrote this question, so I'm specifying the rounding here. Be careful with the rounding. If your teacher specifies a different rounding, you have to use that specific rounding. So I didn't actually specify any rounding here, so any answers that are sort of along these lines are pretty much correct. But if you're told a certain number of decimal places or a certain number of significant figures, that's what you have to do. And this is the answer that we're after.